In section 8.1, when we were graphing a system of equations, I said that's the last time we would graph until we got to chapter 10. Well, I was incorrect in that. We do have this system of inequalities where we have to do graphing. So we're going to take a look at a couple problems on pages 613 through 615. The first one is on page 615, and this is problem number 6, which I've written here. When we do the graphing of inequalities, what we do is we set up our xy points, and of course now we're being more efficient, so we'll say x is 0, and when y is 0, we have to figure out what are the corresponding values. Well, if x is 0 up here, then 0 minus 2y is equal to 8, and then negative 2y over negative 2 gives me 8 over negative 2. Y then equals negative 4. And for the second part, when we do this, we'll have x minus 2 times 0 is equal to 8, so x is equal to 8. So now our corresponding points are 0 and negative 4, which is down here, and then we have 8 and 0, which is clear over here on the right, and we would have a straight line. I'm just going to sort of freehand that. And notice it's dotted, and that's because this is greater than, but not greater than or equal to. The second formula or inequality we have is down below here. 3x minus 2y is greater than 12. So I'll do this. X, y, and again, 0, 0. So when x is 0, we got 3 times 0 minus 2y equals 12. And then negative 2y over negative 2 equals 12 over negative 2. And then y equals a negative 6. The second part of that is what happens if y is equal to 0. Going back and substituting in now, we will have 3x minus 2 times 0 right, is equal to 12. 3x equals 12. 3x over 3 equals 12 over 3. And then x is equal to 4. Now, when we go ahead and graph that, the points that we have are 0 and negative 6, which is down here. And then what we have is the points 4 and 0, which is up here. And when we freehand that one, the graph looks sort of like this. So we have those two inequalities graphed. The last thing we have to do, of course, is we have to determine where we're going to shade this in. So what we do is we take the 0, 0 point for both of our equations. I'm going to erase our work there, and then we're just going to do the 0, 0 point for both of them. In the first one, using the 0, 0 point, we'll have 0 minus 2 times 0 is greater than 8. And if that ends up being 0 is greater than 8. Is that true? No, it's not true. So what that means is we're going to shade on the side that is away from our origin. That's over in here. And for that first equation, it's everything that's below that line. Okay? And that could extend clear over into here. But now what we're going to take a look at is how about the second one? We do the origin. We have 0, 0. And 3 times 0 minus 2 times 0 is greater than 12. Is 0 greater than 12? And the answer to that is no, it's not either, which means again we're going to shade away from the origin. But now we've got a parameter where it is to the right of that equation, and it's down in here. And in order to fill both of those, we have to shade to the right of both of those equations at the same time. Where they cross and we're above either one of those, then we can't shade that area. So the part that we shaded over here on the left, we now have to eliminate because that's not a part of what we're shading. So that's how that works when you have two inequalities. Let's jump on over now and take a look on page 614. What happens if we have three inequalities? And what we're going to look at while I'm erasing my little drawing here, we'll have, I'm sorry, a little bit of red left over, but hopefully not a whole lot, is we've got 3x minus 10, I'm sorry, 3x minus y is less than or equal to 6. Then we have two other parameters here with that. Those other parameters is x is greater than or equal to 1, and y is less than or equal to 3. So I'm going to write all three of those up. 3y, I'm sorry, let's write that again. 3x minus y is less than or equal to 6. The other two, x is greater than or equal to 1, and y is less than or equal to 3. Those we can go ahead and graph right away, so that's why I like to do those first. In the first case, x then, it's going to have to be greater than or equal to 1. So no matter what the value of y, the x is going to be along that vertical axis. Here's 1, and it's going to go this way and down this way. So no matter what the value of y, x has to be greater than or equal to. So you notice I did a solid line. Then it says y has to be less than or equal to 3. Well, that becomes a solid line going across the y-axis right here at 3. So now what you have is it has to be greater than 1 but less than 3. So what that leaves is this area right here. All right? That's less than 3 but greater than 1, and we can shade all of that that takes out toward to the right and below. Now all we have left is our other inequality, 3x minus y is less than or equal to 6. Setting up our parameters x, y, if x is 0 and then y is 0. If x is 0, 3 times 0 minus y is less than, I'm sorry, we put it in as equals to figure out this point, is equal to 6, then negative y equals 6, therefore y is equal to negative 6. That takes care of the first part. The second part, where we substitute 0 for y, what we get is 3x minus 0 equals 6. 3x equals 6, and 3x over 3 equals 6 over 3. X then is equal to 2. And when we take those points and plot them, 0, y is negative 6, we've got that point down here. And then x is 2 and y is 0. That point sits right there. And when we draw the line for that, that's going to be a straight line, because, a solid line I should say, because, and it goes all the way down past here, because it was less than or equal to 6. Now we have to ask ourselves, where can we shade in here? So what we're going to do, of course, is again our 0, 0 point. Going and substituting in 0 for each of the values of x and y. 3 times 0 minus 0 is less than or equal to 6. Is 0 less than or equal to 6? Yes, it is. So that means that what we're going to do is shade in for that portion towards the origin. But when we do that, we start shading, oops, I'm sorry, it should be red. When we start shading in red, what we're ending up is we hit the y is less than or equal to 3 up there. And over here, what we run into is the x is greater than or equal to 1. So we end up shading only in this small area right here. So that's what happens when you have 3 parameters. If you look at number 14, you'll have 4 parameters. But again, for x is greater than or equal to 0, then that happens to be right along the y-axis, and y is greater than or equal to 0 will be right along the x-axis. All you have to do is shade those other 2 parts and determine where it is that you're going to shade in for all 4 of those inequalities. Now what we want to do is take a look at a story problem. I think the story problems are the ones that are most difficult to understand. So we're going to take a look at story problem on page 615, and we're looking at number 20. In that story problem, it says a small firm produces both standard and HD radios. Standard radio takes 15 hours to produce, and the HD radio takes 20 hours to produce. It says the number of production hours is limited to 300 hours per week. So, what we get out of that first statement, actually the first 2 sentences, if we let x equal, and where I come up with that is at the very end of that story problems, it says draw a graph of the feasibility region giving these conditions where x is the number of standard radios. So x is the number of standard radios. Therefore, y is equal to the HD radios. So I didn't just make that up. I got that from the last statement. I didn't read that far originally, but that's where you get the x and y. All right, if it takes me 15 hours to produce a standard radio, and it takes me 20 hours to produce an HD radio, and I am limited to 300 hours. So it has to be no more than 300. So the limit is less than or equal to 300. Now, the next statement in there, this is the third sentence. It says the plant's capacity is limited to a total of 18 radios per week. So what they're giving you is if I have X standard radios and Y HD radios, the most I can do during a week is 18 radios. Doesn't sound like very many for a week, but it can be equal to 18 or it can be less than. That's the maximum capacity that they have, so it's less than or equal to 18. So now what I've got is I've got my 2 inequalities, but I have 2 more parameters. It says there in the next one, it says after the comma, it said, and existing orders require at least 4 standard radios. All right, so X, you have to have at least, so it has to be either more than or equal to 4 standard radios, and they have to have at least 3 HD radios. Once you have those 3 parameters, actually those 4 parameters set up, now what you do is you start graphing the inequalities similar to the way we did problem number 10 on page 614. So you get, I think, problem number 19 on your homework. Use this as a basis for setting those up.